Hello colleagues and friends, participants at the Conference of Scientific Visualization of Modern Computer Graphics, Gaming and Animation 2018. My name is Stefan Doychev, and for me it's a great pleasure to be present at this forum. Today I'll be speaking about designing games in VR, and more specifically, how to deal with the most common problems every VR developer is facing today. I'll address some modern approaches, how to solve those problems, and I'll share some real-life examples from my practice as a lead developer of the award-winning VR game, Sunwalker. Before I begin with my presentation, I would like to present myself. I am part of Hack and Paint, a distributed game studio, and I'm currently leading the development of our first game, Sunwalker. A great accomplishment for my team and me was the very prestigious award we won at the last Game Developers Conference, Best in Play 2018. The Sunwalker VR game will be in the focus of today's presentation, as most of the examples I'll talk about have been actual problems we faced during its development. If you got any questions on the presentation or want to get in touch with me, please drop me a message using the contacts currently on the screen. Let's jump straight to the problem. The traditional game design rules and guidelines do not work when creating content for the virtual reality platform. Due to the limitations of the hardware, some specifics of the new platform, and the immaturity of the current game design and development tools, the VR developers face commonly shared problems. The problems I'll discuss in details today are the state of the hardware used for VR development today and the limitations it has. The weight is still heavy enough for most of the users, and this leads to disruptions of the comfort of the players. Another common problem is the feeling of dizziness most of the VR users express after several minutes of play. This problem is also described as motion sickness. I'll underline the importance of the sound design in every virtual reality application out there, and the ever-increasing need of quality user interface and user experience. Finally, I'll show some optimization techniques used in the development of Sunwalker, which were very useful in terms of increasing the average frame rate of the game, and this improvement in the frame rate led to big increase in the general perception and the experience in the game. A very common problem related to development of virtual reality application or virtual reality game is the feeling of dizziness or sickly side effects after several minutes of playtime. This problem is also known as vection. The main reason for feeling such sickness is the difference between the movement in the virtual reality but not in real life. By design, the main setting and action in Sunwalker was based on a third-person camera perspective, and a lot of prototyping was needed to design a good movement system in the virtual reality that doesn't make the player sick. After several attempts, it quickly became obvious that a fixed camera position would be required in order to restrict the feeling of action for all of our players. In the video now playing, we can see our first prototype, a static camera in VR showing the main character being controlled by the player. There is no movement that would confuse the brain, so no dizziness is experienced. Although the goal was accomplished, and there was definitely no motion sickness, the playable level was very limited, and the player couldn't go further than what he sees. The idea of a second approach came. As shown in the second video, the camera would remain static but would change its position to show different parts of the level. Properly positioned cameras at the edges of the zone visible to the player give the impression of smooth transition. Unfortunately, during the playtesting, we found that you spend 90% of your time looking down with the headset. That caused fatigue in your neck muscles because of the current generation of headsets is not yet lightweight and a further improvement was necessary. The latest movement system implemented, and the one still used today in Sunwalker, incorporated the already known approach of camera changing positions on the level, but those positions were not always overlooking the player from high locations. Instead, some cameras were positioned at eye level of the character, or even below that point, giving the player the opportunity to relax the neck muscles from the weight of the VR equipment. It's important to note that the design of this movement system in VR was completely different than in other traditional platforms, and it took us 6 months to design a system that works. After discussing the main and most serious issue with most of the VR games today, it's time to note some other commonly faced problems by nearly all the virtual reality developers. The current generation of hardware, even though always on the increasing capabilities and image resolution, is still pretty young, and the resolution is not quite a match for the resolutions commonly seen in PC or console games today. Despite the low resolutions available, the final products can still be pretty impressive in look and feel when the production phase is done. Although most of the current game design and development tools are still pretty early in their phases, and some of them are quite immature, we can witness a growing trend in their quality and number, so we could be very optimistic about the future arsenal of tools the VR developers would be able to use. The importance of the sound, both ambient sounds and sound effects, is crucial for a deep, satisfactory and engaging interaction with the virtual reality environment. Not only the players will use the game sounds to orient themselves in the game environment, but will also create subconscious connections between the sounds and the compartment of the in-game characters, patterns in the behaviors of the enemies, etc. As the virtual reality offers us a completely new medium in which the player can truly submerge, it is our goal as developers to deliver a deeply immersive experience. For example, let's take a look at this beautiful mountain and imagine we're walking on top of it. Naturally, the winds would be blowing from different directions. There might be random sounds in the distance, or even some animals might be roaring somewhere far away. There are no isolated sounds in the real world, but combinations of many different sounds mixed together, and it would be highly improbable to create an immersive experience if we include only one sound source in our game. We could build on top of this small example and also say it would be a lot better if the different sound sources have different impact on the overall sound perception of the player. The winds from north might be a lot more severe further north you head. Also, the wind listening might become more intense and the signs of an eventual storm increase. Meanwhile, the southern we head, the lesser the storm sounds are. Another important sphere in which the sound design has to be discussed is the responsiveness of the sounds. In the virtual reality, the player has the opportunity to interact with the surrounding area in many possible ways, and we have to allow him to receive feedback about his actions every single time he's interacting. Imagine we've created a game in which the player has to interact with a rusty lever, as shown in the image. The lever is really rusty and noisy, so even the slightest touch has to be registered. Of course, if we play the same sound every single time the lever is moved, the player won't have any feedback if he successfully moved the lever until the required position in the game. Hence, we have to strive to create natural and responsive sounds with respect of the user, always put him in control, and play appropriate sounds depending on how fast or slow he's interacting with the environment, and also provide appropriate feedback when expected action has been successfully done. There is a saying that even the greatest products are doomed to be forgotten if they're not intuitive to their users, and this is especially true when it comes to a VR application. Creating a good and solid user interface is one of the greatest challenges the virtual reality developers face. The traditional approaches known from creating a user interface in 3D and 2D game worlds simply don't work here. The usual flat display is now replaced with curved indicators. The health and stamina bars are now replaced by actual changes in the feelings of the playable characters, and the standard and common tutorials are now getting discarded by in-game actions or examples. We'll now take a look on several decisions we took during the development of our game. Those decisions formed the user interface and improved the general user experience of the Sunwalker project. In this scene, we could see that over one of the purple blocks there is a button B appearing. This is an example of a new way of creating and showing hints to the players how to interact with the environment in VR. It will only show when all the requirements are met. In this specific case, a puzzle has been solved. In the second example, we notice that the costume of the main character has some glowing elements. Those elements only glow when the heroine is close to an interesting object, giving a hint to the player to expect something new in the game to occur. It is also an example how to discard the traditional UI elements. As a possible approach to mark this event in a traditional 2D or a 3D user interface would be to put an exclamation mark somewhere in the HUD, for example. Such swaps of HUD elements to in-game elements would become more and more often. For example, instead of showing an in-game timer to the player, he could be given a real stopwatch clock counting down the remaining time. A final example to illustrate better the suggested removal of the health bar is the implementation of those electric-like flashes you see next to the character on the screen. In combination with the getting hurt sound effect being played in the game, those flashes are a clear indication of health being lost instead of traditionally showing some fading -1 heart signs up and down. This approach greatly improves the player immersion and satisfaction from the game world. In this final part of my presentation, I would like to present you an overview of some of the optimization techniques my team and me we've used to improve the frame rate of our game. It is important for the VR games to offer a constant frame rate of above 90 frames per second. If the frame rate drops below this count, our research showed that our players immediately notice this change and the dizziness effect begin to occur. It is important to say that those optimization techniques showed good results and made sense in the context of our game, but they might not be valid or might not bring the same results with other games or VR applications being optimized. Remember to always use a proper profiling tool and base your optimizations, predictions, and results on actual observations rather than feelings or subjective estimations. The first optimization technique, which led to crucial improvements, was to reduce the number of draw calls made by the engine. Because of the nature of the graphical processing units, or GPUs, they're usually slow at commands that change their state, while draw commands are pretty cheap. By combining meshes and materials, we've been able to reduce the draw calls made by the GPU and increase the final frame rate by 25%. Also remember to batch draw calls whenever possible. And one very easy way to do this is to use the static batching. In case you're using Unity, you just have to check a flag as shown in the picture behind. It is usually a good practice to reduce or even remove the faces of objects with expensive geometry that will never be seen in VR. Try to stick to this practice as much as possible, or even better, don't waste unnecessary efforts to create a high detail object that would be never shown to the public. For example, if our players will never see the back of a very beautiful wooden frame because it's against the wall, we don't want any of those back frame faces on the model. A great optimization strategy is to implement a mechanism that draws different levels of details based on the distance to a given object. This technique is called level of detail rendering, or LOD rendering, and allows us to reduce the number of triangles rendered for an object as its distance from the camera increases. You can see an example illustrating the idea very good. In case your product is not based on a game mechanic that requires live interactions with light sources or their shadows, you could always bake or light map some of your light sources, as those components tend to be heavy computational-wise and lead to unexpected drops in the frame rate. Also, try to reduce the excessive light sources whenever possible. Generally speaking, there are many more techniques that could help you in your mission to get a solid and decent frame rate for your game. Some of them worth mentioning are the occlusion culling and the anti-aliasing, but the golden rule in the optimization will always be to trust your profiler and to use it often. Dear colleagues and friends, thank you for your attention. For me, it was absolute pleasure to be able to present you this brief overview of the VR development area and its current state. I would like to end this video with a trailer of the game I've mentioned so many times during the presentation, Sunwalker. Please enjoy it and don't hesitate to send me questions or inquiries if you got any. Enjoy the rest of the conference and have a great week in Japan. Sayonara.
What would happen if global warming becomes a reality? Sunwalker. You play as Anne, a lone survivor. Guiding her in her adventure, you find clues about what happened to her and the world around her. By manipulating the environment, you are protecting Anne from the burning sun. A never-ending quest in which you meet a lot of friends along the way. Sunwalker is a VR game